All right, so take a look at this code. This is C code. This is an if statement in C. A lot of other languages would work like this, but in C, we open up a curly brace to start the if statement, and then we close the if statement with a closing curly brace. Very, very simple. Now take a look at this while loop, okay? It's almost the exact same thing. The only difference is we swapped out if for the word while, but we still open the curly brace to start it, and then we close the curly brace to end it. Now take a look at this. This is a switch statement. There are multiple cases in the switch statement, but look at the way we open it, curly brace, and we close it, closing curly brace. All very simple, all very similar. Now let's look at a bash script, okay? Other scripting languages are like this. The POSIX shell is gonna be like this, but take a look at this. How do we close it? FI. What is FI? It's if backwards. I'm not lying to you, that's really how it works. Let's take a look at this case statement. Now I mentioned switch statements in other languages. This is very similar to a switch statement, but it's just called case in this language. So take a look at this. Here's our cases. How do we close it? ESAC. You guessed it, case backwards. Now take a look at this while loop, okay? Just like the if statement from before, we have while, which also takes a conditional. And then how do we close it? That's right, done. Done. So we have if backwards, we have ESAC for case backwards, but we use done here. Take a look at this for loop. How do we close it? Done. Why not rough? Why is it not ROF? Why for while is it not ELIHW? So long story short, this whole video was made because of this comment I got on one of my videos. This comment was hilarious to me. I love it. I thought this was great, and I was like, you know what? You're right. Why don't we have this? We close an if statement with FI, it's the opposite of if. We close case with ESAC. Why don't we close while with whatever that spelling is? Why don't we close for with rough? So today, we're gonna recompile bash to make it do those things, okay? We're gonna accept these brand new tokens. So yeah, let's jump into it. All right, so here we are. We're logged into a Linux virtual machine I have right here. And the first thing we should do is we should probably make a directory to work out of. We're gonna call this ELIHW. I need to get used to typing that because that is while backwards. So let's go work in that directory. Now we're there. Cool. So what's the first thing we need to do? Well, if we're going to modify the bash source code, I think the first thing we need to do is pull down the bash source code. So let me show you guys how to do that. Here we go. Light mode jump scare. We are on GNU.org, okay? So this is where the bash source code is hosted. We can go here, we can click software, and this will show us all the software we have. You scroll down here and there's a lot of software, which is super nice. Take a look at this. Bash, click it. There we go. Now we're in the page for bash. There we go. Stable releases can be found on the main GNU server, and they link to them here, and it's mirrors. Please use a mirror if possible. So let's go ahead and fire open the mirrors and see what we got down here. So there's a whole mirror list. There's a lot of stuff here. As you can see, I've clicked on a bunch of them before. Let's pick a random one. How about this one? There we go. Let's go find bash right here. And let's grab the newest one. We want bash 5.3. So if you scroll all the way down here, bash 5.3.tar.gz, that should be it. So let's copy that link, and then we're going to go back to the terminal. Go over here, and we are going to, you can wget it or you can do curl-O. I like curl-O. I'm just kind of used to it. So we run that, and there we go. Now we've downloaded it. So we have bash 5.3.tar.gz. Cool. So let's go ahead and extract the tar archive. We can do tar xf, the name of the file, and there we go. Now we should have the bash source code here. There it is, bash 5.3. So let's cd into it, and here it is. This is the source code to the bash shell itself. So the first thing we need to do is we need to make sure that we can actually compile it, okay? This is really easy software to compile. You need to run the configure script, and then you'll simply run make, and it will do everything for you. So let's go ahead and run configure on my system. This will probably take a while. It has to go through and figure out everything that's needed. If you've compiled like C or C++, maybe C++, I don't know. Mostly C software that I see comes like this, and it's pretty simple. You just run configure, make, and then make install if you want to install on your system. I'm kind of yapping because I know it's going to take a little bit to run, so I may cut the video. We'll see how much longer it takes to actually run. And there we go. Configure ran. As you can see, there were no errors, so we are good to go. We are good to start compiling it. We can run make right now, and it will try to compile the software for us. What we can also do is we can do -j and then give it an argument. This is how many parallel jobs to run at once. So I'm going to give it a -j of 4 just to run 4 at the same time, just so it'll run a little bit faster. We can put time in front of it, and we can see how long it takes. -j is super great if you know it's going to work, but once you have errors, it can kind of run into some issues. Some software doesn't work super well with this parallelization. So if you have issues, try removing the -j and running it one by one. But I've compiled this before. It should just work, and it's working pretty fast here. So there we go. Looks good to me. Let's check this. We have an exit code of 0. Hey, that's awesome. It took 13 seconds to run. Not bad at all. And when this is done, we should have a bash binary in our present working directory. So if we run this, we can give it like -c echo hi, and there we go. It works. If we wanted to, we could go into it. This is gonna be a little bit confusing. We are now in our custom compiled bash shell. And you have to remember that because when you type exit, you will go out of your custom compiled bash shell. If you get a little bit confused, there is an internal bash variable that can help you with this. Shell level, okay? So we can echo shell level, and this will get incremented every time a new shell is created. So if we run bash here, we can then echo shell level. Oh, it doesn't have it in my history because it's a new shell and I haven't committed my history yet. Echo shell level. Now we're in shell level 2. So that's a useful way to figure out if we're done or how deep we are here. I'm going to do Control D. That will close input, which will automatically exit it for me. So then if we echo shell level, we're back at level 1. So that's kind of one way we can keep track of how deeply nested we are. All right, so what are we going to do here? First thing we're going to do is we're going to look in this file, parse.y. This has all of the logic for, here you can see, yak grammar for bash. So this has a lot of the bash grammar, 1989. Look how far back this license goes, okay? That's incredible. So here's all the grammar. Here's where all the tokens are defined. Here's how bash actually, defines its language effectively. So we can go through here. There's a lot of stuff here, and I'm going to spoil a little part of it, okay? Let's not even make a change yet. Or actually, no, let's make this a little bit easier. Let's make our own little change, right? We're just gonna say, hi. Simple as that. We're just adding our own comment to the file, okay? Let's go ahead and rerun make. This will recompile the software based on whatever changes I made. Now it knows I changed parse.y because the timestamp of the file has changed. Let's go ahead and run make and see what happens. Look at this. It fails, okay? So because that file was modified, the make file knows that it's been modified and it needs to rerun this command to generate the output of that command. If we were to go into the make file, we could actually look for that. I think we can go down here and see that it's defined all caps YACC. We can search for that and we can see that it's only run here. If I just keep searching, I only find that one result. It's run here and it creates a file as a result of running this. Now here's the thing, that file is shipped with bash. So we already had that file, which was great. Now that we've modified parse.y, it wants to recreate that file, and that's when we run into that error of, hey, we don't have this yak command installed. Also, just a fun note, if you've watched my videos before, take a look at that cursor. Look how much easier it is to see the text underneath the cursor. Got a lot of complaints from people saying my big box character was just a giant white blob and it made it really difficult to see what was underneath it. I figured out how to fix it. In iTerm 2, there was a setting called context-aware box coloring. It's weird. I'm not fully used to it yet, but it seems like it's making better content. So I'm going to leave it like this for now because it seems like it's easier to see what's underneath it. So you're welcome. Awesome. So we're going to need the yak command. I am on Void Linux and I have this little wrapper script for XBPS called VPM. So this is how I'm going to do it. If you're on Ubuntu, you might need, apt-get or apt search or whatever. I'm going to do a VPM search just to make sure that yak is there. And look at this. We have Bison, we have byak, and we have Alexa and yak for Python 3. We're probably going to install Bison because take a look at this. It's the GNU yak replacement. We're using bash. It's a GNU project, so why not install this one? So if we install Bison, we should get the yak command with it. So VPM I Bison, it's going to yell at me, sudo VPM I Bison. There we go. Now we're going to run through, we're going to install this software, so it'll be available on our machine. Awesome. Now if we do command -b -v yak, look, there you go. Now it's installed. We're going to rerun that make command. And look at that, it got past that yak thing, so it's successfully built there. Now it's gonna go through and it's gonna recompile everything, and hey, it looks like it worked, so we should just have the bash command available again. Now, we didn't change anything. We just updated the timestamp of the file, so we have to actually go make some changes in the file. So what do you say? Let's go do that now. So the first thing we're gonna have to do is we're gonna have to find out where the tokens are defined, and these tokens will be like built-in keywords to bash, like if, then, else, do, done, things like that. So we're gonna look for, there's a whole bunch of things we can do here. I like just searching for done because it's going to be in a lot of places. And take a look at this. The first one that comes up here. Token, if, then, else, elif, fee, case, esac, select, while, until, do, function, coproc. Wow, look at all those tokens. Wouldn't it be awesome if there was just another one? And wouldn't it be awesome if it was just ELIHW? I'm never going to remember how to spell it. It's so hard. I have to think about that one manually every time. It's while backwards. So there we go. Now we've added the token. Now we're not done yet. There are still some other places we have to add it. So let's go ahead and search for, I like to search for esac because it's a weird word and it doesn't show up much in this file. So let's search for it. And you can see, okay, it's in a lot of places down here. Look at this. Look at this. The word token A list. So these are a list of all the tokens here. Let's go ahead and, add a new one. Let's grab this one, duplicate it, and change this to ELIHW. And change this to all caps, ELIHW. There we go. Now we have a new token for bash to recognize. It doesn't do anything yet, but we're getting there. We're iterating one thing at a time. So let's find the while command, because we have this while backwards. That's great. Let's go find this one and see where it's defined. So I'm just going to search for all caps while, and here we go. Look at this. While compound list, do, compound list, done. So this is what a while loop looks like. While, do, and done. Okay, that's very simple. So let's change done. Now we could just change it to this, but we might break existing scripts. So wouldn't it be nice if we supported both of them? We can do that. We can change this to while underscore end. We could call this whatever we want. This is just basically a variable or placeholder. We're going to define this now. While underbar end. All right, so we scroll down and you can see it's kind of hard to see, but look at this. This line is at the beginning here. We can go ahead and add our own thing here. While underbar end. Now we've defined it. So what does this actually have inside it? Well, originally it had done, but we also support now ELIHW. There we go. Put a semicolon to close it, and that's it. That should be it. Hopefully, we'll see. We'll test my knowledge here, but that should be it. So let's go ahead and recompile that. We'll run make, and we'll see if this works. I love how I showed you guys make -j, and then I just didn't even use it there, so we had to wait the whole time for it to run. Well, I did jump the gun a little bit. We haven't actually come up with a way to test this. Isn't that hilarious? Let's back out of this. We are in the while backwards directory. I don't know what else to call it. Let's go ahead and make a script here, okay? Let's do ELIHW test. So we'll make a script to actually test this syntax and make sure that it works how we expect it. So if this works, we should be able to say something, let's say, while I is less than 5, do echo $I, and then I++, and then done. And let's go up here and let's actually define I equals 0, while I is less than 5, I++, and then we have done here, but that's not actually what we want. Let me change this, ELIHW. Okay, it looks wrong. My syntax highlighter does not like it, but this is the script we want to make sure it runs, right? So we have this script. Let's chmod+x and give it the executable bit. There we go. And let's run it using our current version of bash that we have installed. And look at that, we get a syntax error. Right, that makes sense. It is a syntax error. It is wrong to run it this way. Let's go use our custom compiled version of bash and see if it works, okay? So bash 5.3, bash here. Let's run test. I don't know how to pronounce that. And it works. It absolutely 100% works. We can make sure we could CP this test over to while test. And then we can make a simple while loop test where we change the ending from that back to done. Because remember, I told you it should work for both of them. So if this works how we expected, we should be able to run the while test. That looks good to me. And then this one. That looks good to me. If we use our system installed version of bash, the while test should work. But this new one should fail. And that's exactly what happens. So let's put ourselves in that custom compiled version of bash. We can just run bash right here inside this directory. Now we are in the custom compiled version. So if we echo, what is it, sh level, there we go. Now we're in level 2. So we should be able to write something simple like while true do, what do we want to do? Echo high sleep 1 ELIHW. There we go. Now we're in an infinite while loop using our own custom syntax. How beautiful. Well, what's the next one? We mentioned while. We have to still do for loops. They're a little bit more complicated, and I'm going to show you why that is. So let's go ahead and just search for for. A for loop has many forms. There's like the math version, there's like the sequencing, there's like the basic array in notation. So we have to modify all of them. So here you go. We've defined the for command, for word, new line, do, compound list, blah, 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 done. Instead of done, let's do for end. Just like we did while end before, we will do for end. And we're going to define this below, but let's scroll down and see all of the versions. So this one, we'll change done for end. This one doesn't have a done, so we're not worried about it. Let's go down here. Oh boy, there's a lot here. That becomes a for end. I don't see a done there. Let's go down here. Oh boy, there's a lot. That becomes a for end. Scroll down. I don't see one there. Like I said, a lot here. Look at this. Arithmetic for command. So this is like math arithmetic or whatever. So there's a done here. Let's go ahead and swap that out. There is a, let's keep going. Is there another done down here? I haven't actually spoiled this part for myself, so I actually don't even know if there is any more. Okay, there we go. That's all of them. So let's go down here and let's define it. For end colon. We want to end a for loop with done and rough, which is for backwards. Close that semicolon. There we go. Let's go ahead and run make. And it does not compile because I completely jumped the gun here. I didn't even define rough anywhere. These error messages are really nice. I wanted to show that the error messages are actually useful. So I want you guys, if you're watching this video, don't be afraid to like pull the source code down and mess with it. I'm not saying implement this stuff. This isn't like a legitimate feature. No one would ever actually want this. This is just meant to be fun and educational. But I want to empower anyone watching this to like pull this stuff down, run it. And if you run into errors like this, hopefully these error messages can help you debug it and figure out what's going on. Also, this video hopefully can help you. So we haven't defined rough. Let's go ahead and do that. Well, we've defined ELIHW, so let's search for that. And let's just copy that. There we go. This can become rough. And this can become all caps rough. Let's search for it again because we know it's being used here. Look at this, where we define all those tokens all the way above. Let's go ahead and add that, ROF. There we go. Now it's added. Save this file, run make, forget -J, so it's gonna take a little bit, and then edit the video and you guys won't even know. Look, it's done. How awesome is that? So now we have a new thing that should be able to work with these new for loops. Of course, again, I did things out of order. I didn't actually write a test for us, did I? So let's go ahead and do that. Vim for test. This will be a basic for loop test that should just work because I'm going to use the basic syntax here. For I in 1.5 do echo $I, done. There we go. There's a basic for loop test. I'll show you the source code because I kind of went through that fast. For test here, if we run it like this, it works. Very simple. If we run our custom compiled version with the for test, hey, it works. That's awesome. Let's CP for test over to rough test. Let's open up rough test and let's change for to rough. Now, I know some of you guys might have comments. I've gotten this from other people before. You know, how come it ends in do? Shouldn't it be OD at the end of it? Well, an if statement has then in it. Should it just be then backwards? It could be. We could implement it. But for now, we're just going to do the opposite. So just like if has phi, case has esac, for is going to have rough, and while is going to have eli. I don't know how to pronounce it. So there we go. Let's take a look at rough test. Let's run it with our system's built-in bash, and we get syntax error. Makes perfect sense. Let's go ahead and run the custom compiled bash right here against the rough test, and what do we get? There we go. It works. So this is how you would add custom syntax and tokens to bash. So if you ever looked at a bash script and you thought, well, this is stupid, why can't I end a while loop with while spelled backwards? You can. All you have to do is custom compile bash so it supports that as a token, and then look at that. It works. That's all you have to do. It's not that hard. Yeah, there you go. I hope you found this entertaining, and I hope you found this empowering. Like, it can be fun. You can pull this stuff down and just kind of do whatever you want. That's the power of this software, this open source software that you're free to pull down, mess around with, and just have fun with and learn and just do cool things like this with. So yeah, thank you so much for watching. I appreciate it. If you made it this far, go ahead and hit that subscribe button, okay? What are you doing? I'm trying to hit 100,000 subscribers. I'm at like 78,000 subscribers at the time of this recording. So yeah, go ahead and do that. That'd be awesome. And of course, I can't end a video without saying thank you to my Patreon subscribers, my patrons over at Patreon. Look at this. Oh wow, we have to scroll the terminal. That's how many active members we have. That's incredible. Thank you so much, everybody. Thank you to my patrons over at Patreon for your continued support. That's awesome. I think it's super cool. Yeah, that's all I got. Hopefully this was fun. I kept this one a little bit shorter for you. So yeah, have a good one.